This is serving both as our notes as well as a worksheet, okay? What are we doing? We are going to look at confidence intervals and what we call hypothesis testing. They are together. Do you remember what our formula was for calculating margin of error? That was a simple formula. A simple formula. Everybody got that? There are more complex formulas that we use. That's the simple formula. Today we're going to show you a little bit more of a complex formula and be able to apply this to real world situations. Tom is running for mayor. I know it looks weird we're starting on the backside, but I went through this worksheet. I really think it's best for us to start on the backside. I went through all the problems. I was trying to see what's going to be best for us. A recent sample survey shows that 52 out of 98 people will vote for him. If you're Tom, how are you feeling right now? Talk to the people around you. If you're Tom, how are you feeling right now? What do you need? Okay, talk. All right, what do we got? You're Tom. How are you feeling? You're feeling pretty good? Anybody feeling like, you know what? I'm feeling pretty good, but I'm not feeling great? Yeah. So suppose instead of 52 out of 98, suppose it was 520 out of 980. Would you be feeling better then? Or suppose it was 52,000 out of 98,000. Would you be feeling better then? Yeah, so you can see that number one, you guys looked at it, you said more than 50% of people like Tom. So you're happy about that, right? But you wish that there would be a little bit larger of a sample, right? So we want to see, should he be confident going into election day feeling like he's going to win? Is this a real life scenario? Darn right it is. Let's figure it out. Now, the important part says that his level of confidence, 90%. So what we need to do is see, does this map to 90% confidence? And what we do is we draw our little sketch from yesterday. What goes in the middle? 90%. What goes on that side? 5 and 5. So what is this mark right here? 95%. I need a z-score that goes with 95%. Check your chart. I'm looking at my z-table. If I want 95%, am I looking on the positives or the negatives? Looking on the positives. 1.645. So the question is, does 52 out of 98 give a z-score of 1.645 or greater? Okay, that's what we're testing to see. Does his 52 out of 98 give him a score of 1.645 or greater? So we need a z-score here, and we have a formula for a z-score. It's this guy right here. Z is equal to x minus mu over sigma. Does that look familiar? We've used it before. You can see how I pulled stuff from the beginning of the year to try to prepare you for this point. So we need a z-score, and that's equal to x minus mu divided by sigma. Now, the letters are just a little bit different in terms of what they mean now than what they did earlier. Z is equal to, x is the observation. What we've observed is that 52 out of 98 people like Tom. Let's come up with a percentage for that. How do we come up with a percent? Or we can just divide them, right? 52 divided by 98. So like 53% of people like Tom. We're going to go to 3 decimal places, so we're going to go 0.531. So we got 0.531 minus, what percent of the vote does Tom need in order to win? He needs above 50%, right? So we're going to compare that 0.531, we're going to compare it to the 0.5. He needs better than 50. Divided by sigma. That's all we have to do to come up with the z-score. Does that seem simple enough? Now, the difference is how we calculate sigma. Sigma is calculated this way, right here. Sigma is calculated by taking the square root of whatever your percent was times 1 minus the percent divided by n. That's the new part that's going to give us a little bit of a trouble. And I want us to be able to walk through it so we can understand. First question is everybody okay with where we are right now? Then let's figure out sigma. Sigma is equal to the square root of the percent. What's the percent of people voting for Tom? So I go 0.531 times, and then it's just 1 minus 0.531, divided by n is the total number of people we surveyed. How many people did we survey? 98. So let's be careful and try to figure this out as nice as we can. You definitely want to take out a calculator or a phone or a Chromebook or something to make sure you can calculate this. People got this wrong all the time 2 years ago. Totally messed it up all the time. There's calculators up here if you want to use these guys. These are fine as well. I'm not going to type the whole thing in. I'm going to do it bit by bit. I'm going to go 0.531 times 1 minus 0.531. And I get that. What's the next step? Divide by 9. Well, take my answer that I got. I divide that by 98. And then what? So I will square root that answer right there, and I get 0.050. So I've got 0.531 minus 0.5 divided by 0.531 minus 0.050. Oh, sorry. Minus 0.5 divided by 0.050. And that's going to give me my z-score. 0.531 minus 0.5. I press enter to get 0.031. And I divide it by 0.050. And I get 0.62. 0.62. Does 0.62 place me to the right of 1.645 or to the left of 1.645? No, he can't be confident enough. In fact, if we looked at our sheet at 0.62, I got like 0.31. I'm sorry, if I look at 0.62, I've got, let's see, 0.62. That's only 73% confident. This only gives you 73% confidence. He wants to have 90% confidence he could go on election day with a win. That 0.62 we came up with, that's only 73%. It's not good enough. See that? A student does a taste test comparison between generic pop and name brand pop. Do you think you could tell the difference between generic pop and name brand pop? Tell your friends what you think. Go. Make sure you give an example. Okay, anybody think that they just really can't? Like they buy the off-brand because you just buy the off-brand. Okay, give us an example, Trey. Okay, grape pop. So I would argue there that I'm fine with the grape pop so long as it is as it's got like the corn syrup. But like if you do the grape pop, like anybody ever go to like some stores sometimes and they got like the natural grape pop that has like real sugars instead of the corn syrup. Like sometimes I feel like I could tell the difference with those. But for the most part, you know, you're saying, hey, I'm going to buy Hy-Vee brand or I'm going to buy, I don't know, what is it, Sunkist grape, something like that. It kind of all tastes the same. Or like orange pop. Oh, orange pop is kind of the same. Root beer. So you're a root beer connoisseur. So what is the root beer that you feel like you know? Like if you taste that root beer, you got it. A&W? Barks? Mug, 1919? 1990 is some good stuff, isn't it? Yeah. I hear you. Well, there was a taste test on 7 out of 12 students prefer the name brand. Can you be 90% confident that the majority of people prefer the name brand? You're saying no. Okay? And after you've seen our previous example, you probably feel even more confident about that, don't you? But you don't know until you do the test. We need it. We need a Z-score. Let's figure it out. So first of all, let's figure out this 7 out of 12. What percent is that? Somebody give me a percent for 7 out of 12. 58.3, very good. So I got 0.583. How confident do we want to be? 90%. This kind of makes a chart just like we had last time, doesn't it? So we've got 90 in the middle. We have 5% there and 5% there. So we're looking for the 95% mark, which is a Z-score of what? So let's see if that 7 out of 12 can push past the 1.645. We'll check it out and see. You guys tell me, what do I plug in? .583 minus 0.5, because we would say 50%. Like if you just guess at random 50% of the time, you're going to guess the generic pop from the real pop, right? Or you could do a random number sampling and get that. Divided by sigma. How do I come up with sigma? Yeah, I got that 0.583 times 1 minus 0.583 divided by what is n in this situation? It's 12. We only surveyed 12 people. Turn my calculator on. 0.583 times 1 minus 0.583. I get that, and I divide it by 12. Now what do I have to do? Square root. We get 0.142. Let's try it. 0.583 minus 0.5. Make sure you press enter after that, and then divide by the 0.142. And we get 0.584. Does that bring me to the right or to the left of the 1.645? So, no, we cannot be confident enough. This guy? This guy? This guy. Got it. Thank you. Okay. So this sigma value that we want to find, it comes from that right there. And what we do is P means your proportion or your percentage. So our percentage was 0.583. We multiply that by 1 minus 0.583. It's got to be a percentage. It has to be something out of something. And you guys, we are only showing you one type of test. This is a proportion test. There's multiple statistics tests. We're just going to do really one. And then we divide it by n, which was the number of people we sampled, square root. Is that better?
Yeah.
Okay. So far, you're thinking pretty easy. Let's put it to a real test. A new medication has come out to help prevent influenza. They want to see if it works, so they do an experiment. 1,200 people receive medication. They have 1,200 people who receive a placebo. So basically 1,200 people, they receive a pill, and the other 1,200 people, they receive a pill that has nothing maybe but sugar in it or something else, okay? And what they find is that 98 of the people who receive the medication get influenza. 129 who get the placebo get influenza. It looks like the medication might have an ability to reduce influenza, doesn't it? Can we say with 99% certainty that the new medication reduces the chance of getting influenza? Talk among your peers. Decide, what do you think? Don't perform it. What do you think? Go. Yes. Let me pause this video real quick. Okay, what do you think? Yes or no?
No.
You're saying no. Why?
Well, you mentioned yesterday that, well, I don't think those numbers are very big.
So what you're saying is that you want more than 1,200 people. You want 20,000 people.
And the 98 and 129.
Okay, so you're saying the 98 and 129 are so close together. You're saying if it was, say, 15 and 129, you'd be more likely to say yes. Okay, and we're doing everything based off of gut feeling, right? But the fact is that gut feeling is not enough, is it? Okay, and that's why we do the test. Does anybody feel like it is going to be significant enough of a difference? I'll tell you this right now. It's close. Let's check to see which side it ends up on, okay? Really what we want to do is we want to compare these two results. We want to know, how does 98 over 1,200, how does that compare to 129 over 1,200? Right? I mean, isn't that what you're wondering? How big of a difference are those two things, right? How big of a difference are they? Let's get percentages for each to 3 decimal places. $98 divided by 1,200. And I get 0.0816. I'm going to write it like that. And I'll do the next one. I'll do 129 divided by 1,200. And I get 0.1075. Is everybody okay with my start so far? Let's make our chart, because we've got a new chart. It's different this time. What goes in the middle? 99%. What goes on the outside? 0.5% and 0.5%. So what's this mark right here? It's 99.5%, otherwise known as 0.9950. Can anybody look at their sheet and determine the z-score for 0.9950? Good. 2.575. You've got it. That's my mark. I got to get to 2.575 or higher in order to be different. So let's find a z-score. Z is equal to, let's compare these two. 0.1075 minus 0.0816. Just always use the bigger one minus the smaller one. That way we always do with positive ones, right? Notice how we're looking for the positive side over here, not the negative side. Just always use the positive side. What value do I have to figure out still? Sigma. Got to figure out sigma. Sigma is going to be equal to the square root of, this is the one we believe makes the difference, right? So 0.0816 times what? 1 minus 0.0816. And then how many people were surveyed that gave us the 0.0816? 1,200. So I'm going to calculate that. 0.0816 times 1 minus 0.0816. I divide by 1,200. And what do I do with that result? .008. Can we go with .008? All right, here's the moment of truth. We all said no, right? 0.1075 minus 0.0816. Enter and divide by 0.008. 3.24. Does that bring us to the right or the left? 3.24. So yes, that is enough. That is enough, which is interesting because when I first did this, my response was 100% the same as yours. It doesn't seem like, a reduction of 20 or 31 cases is really enough to say that it makes a significant difference. But when you hear that idea, significant difference, that's what this means. Significant. Significant of 99%. We can be 99% confident. Now I could switch this. Can we be 99.99% confident? Well, maybe not. We would have to change it up a little bit, right? Have to change it up a little bit. But the fact is that that level of certainty is what's decided by communities. They're like, how certain do we want to be? And that changes the way that we operate with the statistics to some degree. We okay? All right, that's enough for one day. You guys have the introduction tomorrow. We hopefully make more sense of it and make it more clear. Good work.